Hey everybody, it's Mr. Lauer here. In class today, this is the day 3 lesson, we talked about perimeter and area. So if you're in A day, this is March 17th, Wednesday. If B day, this is March 18th, Thursday. We started this in class and we talked about some of these key ideas. And then this is also going to be your homework. So it's kind of a combination of notes and homework. We're talking about perimeter and area here, and before we get too far into those definitions, I just want to talk a little bit about dimensions and measurements in different dimensions, okay? So, off to the side here, I'm just going to show you a couple things. Let's talk about one dimension for a second. Okay, a one-dimensional measurement would be like a length. Okay, and this would be like a one-dimensional figure. It's just like a line or like a line segment. Okay, so let's say this guy had a length of 10 meters. Okay, so this one-dimensional measurement is called length or distance. We talked about distance formula earlier. And our units are like meters, inches, or something like that. Okay, so let's go up into 2 dimensions, okay? So 2 dimensions, now I have measurements in 2 different directions or in 2 different planes. Okay, so like a 2D object or a 2-dimensional object would be something like this. Okay, so there's like a length and a width. It's not just one measurement, there's like 2 measurements going in different directions. Okay, so let's say that this is like 4 inches and let's say that this is 3 inches. Okay, the measurement of 2-dimensional shapes here, the inside of a 2-dimensional shape, is called area. Okay, area is like how many squares will fit inside of this thing. We want to kind of fill up the space of this object. So to show that, or to demonstrate that, we can draw some lines in here, kind of like this. And so you can kind of see that here's, 1, 2, 3, 4 inches by 3 inches, and that makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. Okay, so the area here is, in this case, is 12 boxes. Okay, and so how we say that, instead of boxes, we say square inches. And so this little 2 right here is not squaring anything. We don't do anything with that. It's just part of the label. Zoom in so you can see that a little bit better. That says we're talking about boxes. So the units that we're talking about here, whatever we're using, they have this little 2 they have this little 2 up there. So if this is, like centimeters, then this is square centimeters, right? Or we could have inches here. We have square inches. Okay, so an inch and a square inch, an inch and a square inch are 2 different things, right? An inch is a unit of length, like a one-dimensional measurement. Okay, a square unit or a square inch or whatever is literally a square, and for area we're talking about how many squares fit inside. Okay, so your units when you're talking about area are going to have this little 2 on it: centimeters squared, inches squared, things like that. Okay. Now we can go up one more dimension, and now we're going to have 3 directions. So you kind of have to use your imagination on this, but imagine we have like a length and then like a width. This is going like into the page, and then we have a height. So we can kind of draw something like this. Looks kind of 3-dimensional, like a cube. Okay, so maybe something like this, like my little Rubik's Cube here. Okay, and this is a 3-dimensional object, and there's 3 measurements. There's like a length, and then like a width, and then like a height. Okay, so let's say that this was like a Rubik's Cube, 3 by 3 by 3. Kind of draw the little squares out here. Okay, so the measurement of a 3-dimensional figure, the space inside a 3-dimensional figure, is called volume. Okay, and our units are cubic units, right? Units to the 3rd power. Literally little cubes. How many little cubes will fit inside this bigger cube, okay? So if you look at this one, it's 3 by 3 by 3. There's 9 on the top, there's 9 in the middle, and there's 9 on the bottom. That's 27 in total, and 3 times 3 times 3 is actually equal to 27. So let's say that these are inches, inches, inches. It's 27 cubes, 27 little mini cubes. Okay, so that's just kind of a quick intro to dimensionality, because we're going to talk about dimensions a little bit. Now, we're mostly going to be dealing with these 2 dimensions in our worksheet today, but when I say something like 2-dimensional, 3-dimensional, I want you to understand what that means. I also want you to understand that the units are different for length and for area, okay? Okay, so going back to this guy, now that we kind of understand that, let's talk about perimeter, okay? So perimeter is a 1-dimensional measurement. Perimeter is like a length, okay? So it is a 1D, I'm going to use 1D for 1-dimensional measurement of the distance around a 2-dimensional shape. Okay, so we just said the measurement of a 2-dimensional object is area if we're talking about like the inside space. So let's kind of draw this out so that this makes a little bit more sense. So let's do a rectangle here. Okay, and let's say that this guy is 10 and this guy is 3. Okay, well, if this is truly a rectangle, has 4 right angles, and we know that this side has to be 3 as well, and this side has to be 10 as well. So the perimeter is a distance. It's a 1-dimensional distance. So we're not talking about the space inside. We're talking about this guy, like if we were to walk around the outside of this shape. So 3 plus 10 plus 3 plus 10 is equal to 26. Let's say that these are centimeters. Okay, so just 26 centimeters. That's the distance around. Imagine that I took the outside of the shape. Now we're only dealing with the outside of the shape, and we like unrolled it. So we got like the side, and then instead of drawing my next side out here, let's say I fold it over, and I just kind of unfold this box here. And so I have like a side length, and then a long length, and a side length, and then a long length. So 3, 10, 3, 10. You kind of get like a distance, right? So imagine you cut this line here, and then unfold this guy. You're going to get like a straight line that's 26 centimeters long. So that's what perimeter is. It's the distance around the outside of an object. To find that distance, essentially what you're going to do is add all the side lengths. Okay, and because we're talking about side lengths, that's why this is 1-dimensional. Okay, so our units are like centimeters. Okay, so area, remember, is like the space inside, and the units are completely different. The units are squared units, so it's literally how many little squares can we fit inside the shape. Right, so area is a 2D measurement of the space inside a 2D shape. Okay? Or in other words, it's like how many little squares fit inside of a shape. How many square units fit inside of a shape. Okay, so let's go back to our same example here. Actually, let me change it up just so we can draw it a little bit easier. Let's do 3 and 4 like we did. So remember, 3 times 4 is equal to 12, but it's not 12 centimeters, it's 12 square centimeters. There are 12 squares inside of this guy. Okay, so that little 2 again means square units, square centimeters. Okay, so to do this, what we did is we multiplied the base times the height. So area equals base times height of this. Now that's true for rectangles. We're going to see a couple different formulas in a second that will maybe be a little bit different, but we're definitely going to use the base and height together. All right, so now we can practice. Okay, find the perimeter and area of each. So what we need to know here is that This is 6 and this is 3, right? The little inference there. We know it's a rectangle because there's 4 right angles. So the perimeter is 3 plus 6 plus 3 plus 6, right? It's the distance around the outside. 3, 6, 3, 6. Add those all together, we're going to get 18. And these are just yards. It's just a one-dimensional measurement. It's just a distance, a length. Okay, again, imagine we like walked this far, and then we walked this far, and then this far, and then this far. Okay, that's how far we walked. It's one-dimensional. Okay. Now for area, we're going to multiply 3 times 6 and get 18. Now that number is the same, but the units are different. Okay, so 3 times 6 is 18, but these are square yards. So a yard and a square yard are different dimensions. They're different types of measurements. This is one-dimensional, this is two-dimensional. So if I were to draw my lines in here, there's 3, and then I did like 3 by 6, right? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares, right? So 18 squares, 18 square yards. Okay, so that's kind of the difference. Even though the number is the same, these units are completely different. Okay. All right, so you're going to do number 4 on your own. I'm going to kind of jump down here and talk about parallelograms. Okay, so first let's talk about what a parallelogram is, and then we're going to derive, which means use what you already know to find a new formula. Okay, so here's a parallelogram. A parallelogram looks like a rectangle that kind of got smushed. Okay, so what we know about a parallelogram is that this side is the same length as this side. Okay, I'm going to call this side B for base. And since this guy has to be the same length, I'll label it B as well because those are going to be equal. Okay, I'm also going to call this side A just because, I don't know. And then this one I will call A as well because these guys have to be the same. So it's like a rectangle, but it doesn't have right angles. Okay. Now what we want to show here, we want to show the area formula, and we're going to base this on something we already know. So we're going to take this thing and we're going to try to force it to be a rectangle. So I'm going to draw a little dotted line here, and that dotted line is going to form like a right angle. And basically what I'm going to try to do is cut off that edge, that extra piece, so that I have just like a flat side here. Okay, so let's draw another picture that's showing what's happening here. Kind of a progression. Okay, so I cut off that triangle piece. And then this is kind of what's left. Okay, so the top is still B because when I cut off the triangle, I didn't shorten B at all. I just didn't cut really anything off of it, but I did cut a chunk off of it down here. So the top part's the length is B, that hasn't changed, but this is now shorter, and I cut off this little piece here, okay? And this is A, and this is A. So what I'm going to do with this little triangle is I'm going to bring it around here, and I'm going to attach it to the other side of the parallelogram. So what we're going to get is something like this. Okay, so this side's B. It's always been B. It hasn't changed. I never shortened that side at all. Okay, but I cut this chunk off here, and then I put that same chunk over here. So now that I've added this piece back on, this whole length is now B also, because I took the chunk off of here and moved it over here. Okay, now this length, this side, is not A. The A is the diagonal piece. Okay, so A is a side of my parallelogram, but it's not the height of this guy. The height is this straight line where I cut. That's the height. So I need a new letter, a new label to represent that. So I'm going to call that H and H. So this is A. That's how long A is. This is the height of that parallelogram. Okay, so this guy's H, this guy's H, and this guy's H. Right? And so when we put it all together, here's what we got. Now notice that this is now a rectangle. The area of this rectangle must be the same as the area of this parallelogram because it's the same space. We just moved the space around a little bit. And the area of this we could find by doing the base times the height. Okay, so the area of a parallelogram, so I'm going to do A and then what we call a subscript. So area of a parallelogram, the subscript is a little bit lower than the line you're writing on, is equal to the base times the height. So kind of just like a rectangle. Okay. The thing that you have to keep in mind, and that's a little bit tricky, is that you're not going to use the side length here. You're going to use this measurement. Okay. You're going to use the height measurement, and the height measurement is not, for a parallelogram, the height is not the same length as this side. So kind of keep that in mind as we go forward here. All right, let's take a look at a couple examples before we do the triangle. So let's flip it over, or let's go to the next page, and we got a few parallelograms to practice on. Okay, now notice in these examples that you have these dotted lines, okay, like this guy right here. That's measuring the height of your parallelogram. Okay, and sometimes you have that dotted line outside the parallelogram, and that's okay. These are measuring the height of your parallelogram. So remember, this length right here, that's not the height of your parallelogram, neither is this. So even if we knew those, which we don't, it wouldn't help us because we don't want these measurements, we want the height. So the area of this parallelogram is equal to base times height. Here's the base, here's the height. So this is 6 square inches, okay? 6 inches squared, or 6 square inches. Because we're talking about area. Now, one thing to notice as well here is that sometimes those dotted lines go sideways, and this is kind of weird. So this dotted line, again, is measuring the height of your parallelogram, which means this parallelogram is kind of sideways. So think about, maybe this is the ground. Okay, so this is your base, and this guy is your height. So area is equal to the base times the height, which is 74 square kilometers. So the orientation or the direction that the parallelogram is facing can change. It's not always necessarily the same. This line here that we're talking about, this line that measures the height, is called an altitude. So I don't know if you ever have heard that word in relationship to planes, but airplanes, when they fly, the altitude is how high they are, how high the plane is flying. In math, that word altitude also refers to height. It refers to a height measurement, or something that's measuring height. So this guy right here is called an altitude, and it's measuring the height of this parallelogram. So here's the base. Okay, here's like the ground, and here's a measurement off the ground, like if we're measuring straight off the ground. Okay, something like that. So base, height. Let's go back and take a look at triangles for a sec. Okay, so draw a figure to help you derive the area formula for triangles. So we're going to start with a triangle here, and this is going to be, we don't have to draw the triangle like this, but I'm going to draw what's called a scalene triangle. Okay, looks something like this. So let's say we want to find the area of this guy. Well, to kind of figure out what that area would be, we're going to do kind of an experiment, and we're going to double this. So we're going to take this shape that we got, sorry, just trying to make it look accurate. That's not perfect, but you get the idea. Okay, and we're going to break another one. So we're going to double it. Okay, those are not very good copies, but you get the idea. Let's say that this side is B for base. We'll call this guy A. Okay, so B and A, B and A. Okay, now what if we took this shape and we flipped it over so that it was on top? So this side is going to come all the way around and be right here, and the bottom is going to come all the way around and be on top. Okay, let's see what that would look like. So we have the bottom, B, and then we have this side A, right? So we have this like triangle here. And then we put another one on top of it. So this side comes all the way around and sits over here. And the bottom comes all the way around and sits on top. Oops. All right, and we get something like this. And this is A, and this is A, right? Because we took this A and flipped it over here. And this is B, and this is B. Okay, notice that that looks a whole lot like our parallelogram, right? So if you double the triangle, any triangle, if you double a triangle, you're going to get a parallelogram. And we know the area of this parallelogram is base times height. Now, we don't have the height measurement in here, but if we wanted to, we could draw it. You know, we could draw it like here. Right? That would be like our height measurement. But this is kind of the idea that the height of a the area of a parallelogram is base times height. Now let's go back to our triangle. Now the triangle is really what we were interested in, not a parallelogram. We already talked about a parallelogram. But what we can do is we can use what we already know to derive or come up with the formula for the area of the triangle. So notice the triangle is half of this, right? Because we doubled it to make this parallelogram. So this is half of this parallelogram. So the area of a triangle is basically half the area of a parallelogram. So 1/2 base times height, half the parallelogram. Another way to write this is base times height over 2. Those are equivalent. Okay, so that's how you find the area of a triangle. Base times height over 2. So let's take a look at some triangles. So we're going to have to go a couple pages down. So notice, again, we have these dotted lines. Okay, this guy right here is not the height of a triangle, and neither is this. Okay, this is the height of the triangle. It's this line measuring the height, and remember this is called the altitude. So that's the name of the line. The measurement of the height is 3.8. Okay, and then this is the base, 7.4. So if we want to find the area of this triangle, it's 1/2 times the base times the height, or you could do base times height divided by 2. Either way, that will work. Okay, you just got to know how to find the height of those triangles. And so you're looking for that dotted line, that dashed line that represents the height measurement, and it's called an altitude. Okay, so when I punched that in my calculator, I got 14.06 kilometers squared. Remember, this is square kilometers. How many little squares will fit inside that? Because we're talking about area. Okay, area, the units are square units. Okay. Now notice on some of these, the altitude is outside of the triangle, and that's okay. So we have our triangle here. Here's the base, right? Base equals 7. So think of this as the ground. Okay, so here's the ground continuing. It's outside of the triangle, but that's okay. Our triangle is sitting on the ground here, and this is how we measure the height, right? It's at a right angle to the ground, straight off the ground. So this is how high our triangle is. This is the base of the triangle. Okay, going back to the front page, kind of finishing up the front page. An altitude is that dashed line that measures height. So it's a line segment, a section of a line. Oops, I spelled segment wrong. Okay, line segment. It's usually dashed, like not a solid line, that measures the height of a shape. Okay, another thing we need to know about an altitude is always drawn perpendicular to the base of that shape. Okay, so if you say here's the ground, right, and you have a shape sitting on the ground, you're going to measure it like this. The altitude will make a right angle with the ground or the base. So this word perpendicular means it forms a right angle. So this altitude will make a right angle with the base. Now the tricky part is the base isn't always on the bottom. Okay, so let's again go back and look at one of our parallelograms. When you're when you're trying to find area, always start with the right angle. Okay, look for the right angle. There it is. So here's our altitude, right? So that guy is measuring the height. Height equals 6. Notice there's a right angle here. So the right angle is between this guy and this guy. If this guy's the altitude, then that means this is the base. Okay, kind of weird. The base doesn't have to be on the bottom, but the base does have to be perpendicular to the height measurement, or the height has to be perpendicular to the base. So look for that right angle, because that will kind of show you where the height is and where the base is. And then you can use those numbers to find your area. Okay, now that's all kind of like just some basics that you might have already known. Like perimeter and area are probably words that you've seen before, I would imagine. You've probably found areas of rectangles for sure, maybe even triangles and parallelograms. But this is all just getting us started. We're just building here. What we really want to do is we want to talk about perimeter and area in the coordinate plane. Let's talk about what that means. Okay, so the coordinate plane is one of these. This is called a coordinate plane. It's what we put our graphs on. Okay, has an x-axis and a y-axis. And so the goal of today is to graph shapes in the coordinate plane and then find their areas and perimeter. So we need to start by plotting points. Okay, so let's take this guy. This is point Q. Okay, well, we're going to plot and label the points. So point Q is at -5, 4. So I'm going to put a point there. I'm going to call it Q. Okay, point R is at -2, 5. So -2, 5. Okay, we got point S is at -2, -3. So -2, -3, S. And then we got T is at -5, -4. And we're going to kind of connect these in order. So I'm going to connect Q to R. I'm going to connect R to S. I'm going to connect S to T. And then I'm going to connect T back to Q, or Q to T. So notice I have a parallelogram. Okay? Now what we want to do is we want to find, eventually, we want to find the perimeter and area. Okay? So we have to, figure out what those are. But we're going to start by finding the lengths of all the sides. Some of these sides are going to be easy to find, and some of them are going to be a little bit more difficult to find, or they're going to take some more steps. So let's take a look at the ones that are easy. So this side, QT, or T to Q, is 1, 2, 3, 4, 5, 6, 7. It's 8 long. So the one that connects Q to T is 8 long. That's what this means. So there's a little line. This is the line segment connecting point Q to point T. Is 8 long. Now, there's not inches or meters or anything, so what we say is it's 8 units, and that's just 8 of these lengths. There's another one that's the same length, and that's the one that connects R and S. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 8 units. Okay, now Q and R are a little bit trickier. So a lot of times people are like, oh, this is 3 long, but it's not 3 long. So we have to go back to something that we talked about, and that's the distance formula. How do we find the distance between 2 points? We have to kind of form a right triangle. So the distance from Q to R is not 3. Okay, what we need to do is we need to calculate it using right triangles. So I'm going to grab a different color here. I'm going to grab a pencil so that we don't get confused. What I'm going to do is I'm going to draw a right triangle here, and this is not part of the shape, but it's a tool that I need to use to find the length of QR. Okay, so when I draw that right triangle, this side of the triangle is 1 long, and this side of the triangle is 3 long, and I want to find this side of the triangle. So let's kind of come off to the side, and let's show what that's happening. We'll just kind of zoom in and show it a little bit bigger. So I have a right triangle. It's 1 on this side and 3 on this side, and I want to find this. So distance formula or Pythagorean theorem, right? I need to take 1 and square it, and I need to add it to 3 and square it, and then I need to take the square root of that answer. So that's the square root of 1 squared is 1, plus 9, which is the square root of 10, and we got to see what that is. So let's do square root 10. Okay, the calculator shoots you back out a square root of 10 because that's as simplified as it can get. So instead, we're going to convert it to a decimal, and we're going to approximate it. So it's about 3.16 or so. So it's not 3. It's actually a little longer than 3. Okay. Now remember, that triangle is not part of my shape. It's just a little helper shape that I drew to calculate this distance. So this, if this is 1 and this is 3, this is 3.16 on this side. Right? That's this guy. Now, if you wanted to find the other side, this guy, we know it's going to be the same because it's a parallelogram, but also if you drew a triangle, it would be that same right triangle. It would just look like this. So 1 over here, 3 over here, and you want this side. Right? But it's still the same idea. You got to square 1, you got to square 3, add them together and take the square root. It's still going to be still going to be the square root of 10, which means this is going to be 3.16 units. Okay, so for perimeter, I need 8 plus 3.16 plus 8 plus 3.16, all added together. And remember, that's a one-dimensional measurement. We're not talking about space inside. We're talking about a length, basically, a distance around, or all 4 lengths added together. So 8 plus 3.16 plus 3.16. Okay, gives me a fraction, so I'm going to change that back to a decimal. So the perimeter is about, I mean, we rounded here, but about 22.32 units, right? Just units, because we're talking about length. Okay. Now the area, we're going to have to do base times height, basically. So the area is equal to base times height. Okay. Now this is where students get this wrong all the time. So this is maybe what you're thinking. You might be thinking to yourself, okay, I need to take 8 and I need to multiply that by 3.16. And that's my area, right? And the reason why a lot of students do that is because they have this shape like this, and they know this is 8, and they know this is 3.16. And they're used to doing areas of rectangles. And so they're like, oh, multiply this side by this side. But that's not how you do parallelograms. It's base times height, but your height, remember, has to be perpendicular to the base. So we don't want this measurement or this measurement. We don't want 3.16. We want this one or this one. Those is what's measuring our height. So how high is that? Well, that's 3 long. Okay, so here's the base of 8. Here's the height of 3. So this is like an altitude. I should probably have done it like a dashed line, right? Kind of like that. So once again, the height of the parallelogram is always perpendicular to the base of the parallelogram, where they form a right angle. And the height is not necessarily one of the sides of your parallelogram. Okay? Now this parallelogram is kind of funky because it's like sideways, right? It looks like the base is over here. We can't really use this as a base because it's not, I don't know, it's not flat. It's kind of like slanted. And so this is going to have to be our base, and this is going to have to be our height, which is kind of weird because it kind of looks like it's on its side here. So the area of this guy is the base, 8, times the height, which is 3. Okay? And so that's going to give you 24 square units. Okay, now notice that this time we put a little 2 up there because we're literally talking about 24 of these squares crammed inside of this parallelogram. So you got to use distance formula to find the slanty parts, but for area, you don't need the slanty part. You need the altitude. All right, so you're going to have to draw in that altitude. All right, one more. Let's take a look at 18. Okay, now this is going to be a triangle, which is going to make this a little bit more tricky. because we're going to have to use the distance formula more than once. So let's start with plotting our points. -1, 3, 4, -1. So I should label them as well. X, Y, and then Z is -3, -1. So be real careful when you plot your points, because if you get your points in the wrong spot, every other part of the problem is going to be wrong. So you got to start with the correct shape. So we have a triangle. Okay, now we want the length of this guy, right? X, Y. But it's like a slanted, so we're going to have to use the distance formula. Okay, we also want the length of XZ slanted, so we're going to have to use the distance formula. This one, though, this one we can find. The line that connects point Y to point Z, that one we can do. So let's count. 1, 2, 3, 4, 5, 6, 7. Okay, so the one connecting Y and Z is 7. To find the slanty ones, we're going to have to use the distance formula, or in other words, the Pythagorean theorem. So what I'm going to do here is I'm again going to add some helper lines. These are not part of my shape, but they're going to help me find the length of this hypotenuse here. So this is 1, 2, 3, 4 long, and this is 1, 2, 3, 4, 5 long. And so what we have here off to the side is we have a right triangle, and the legs are 4 and 5, and we want to find this guy, the distance between these 2 points, or the hypotenuse of this triangle. So we got to do 5 squared, add it to 4 squared, and then take the square root. So this is the square root of 25 plus 16, which is the square root of 41. Okay, and that's going to come out kind of ugly. So let's take a look at that. Okay, so about 6.40 or so, if we're rounding to the nearest hundredth. All right, so that was the one that connected X and Y. Now I actually have to do that again here because I got this other slanty side. So 1, 2, 3, 4. So 4 and 2. So my other right triangle looks like this. And I got to find this side. Right? That's my distance there. So I got to do 4 squared, add it to 2 squared, and then take the square root. So square root of 16 plus 4, so that's the square root of 20. Or about 4.47. All right, so perimeter is going to be this length plus this length plus this length, all 3 added up. Okay, and I already have those guys. So 6.4, 0 plus 7 plus 4.47. Sure that's a decimal. 17.87 units. Okay, that's the distance around the outside. It's a one-dimensional measurement. Area is going to be how many things fit inside. So for a triangle, we know that the area formula is 1/2 base times height, or base times height over 2. The question is, where's the base and where's the height? Well, let's assume that this is the base. Okay, sometimes the base is on the bottom, that's okay. We basically want one of our straight sides to be the base. So like over here, we picked one of the straight sides to be the base, not the slanty ones. The slanty ones don't make very good bases. So we pick one of the straight sides to be the base. In this case, there's only one. So, and by straight I mean it's like it follows like the lines. It matches up with the lines somehow. So where's the height? Okay, so a lot of people will they'll do like 7 times 6.4 or 7 times 4.47. But remember, the height is not any of these sides. This is not the height of the triangle. This is not the height. This is not the height. The height is perpendicular to the base. So I'm going to draw a line that creates a right angle with the base, and this is my altitude. Okay, that will measure my height, and that is 1, 2, 3, 4 units. Okay, so I'm just going to make a note that the height is 4 units. Now you also see that altitude here and here. Right? All those are kind of measuring the height, but they're all perpendicular to the base. And that's the key. Whenever you draw an altitude, It's got to be perpendicular to the base. Okay, so for area here, what I need is 1/2 times the base, which is 7, times the height, which is 4. And when you put that all together, you're going to get 14 square units. Okay, so you got a few to do. We didn't do all of them, but we did a big chunk of this. So you're going to go back and finish, the practice ones, the easy ones. These are just for practice. This is not really the point of the assignment. This is just almost like a review of area and how to get it. The main idea here is that we want to be able to find perimeter and area in the coordinate plane, like with graphs of shapes. And then later we're going to take some of these shapes later this semester, and we're going to move them around. We're going to like flip them and rotate them and slide them across. And that's kind of, these are more like geometry ideas than they are algebra ideas. So finish that up for your homework tonight. Make sure you turn it in via Canvas and then put it in your notebook so that you can use it on tests and quizzes. Thanks for watching.